A 16 mm thick gusset plate is connected to a 12 mm thick flange of an eye section using fillet welds on both sides as shown in the figure. The gusset plate is subjected to a point load of 350 kilonewtons acting at a distance of 100 mm from the flange plate. Size of fillet weld is 10 mm. The maximum resultant strength on the fillet weld along the vertical plane would be. So he asked maximum resultant stress. So for maximum resultant stress in the fillet welds for these types of loading is F square plus 3Q square, whereas F is the normal stress and Q is the shear stress. That is normal stress along the plane of bending, Q is the shear stress. So shear stress is equal to shear force upon area. So what is the area that is being resisted? So welding is done on both sides. Welding is done on both sides with throat thickness T and depth D. And here also welding is done on both sides with throat thickness T and depth D. So here throat thickness is equal to 0.7 times the size of weld, that is equal to 7 mm. T is equal to 0.7 times size of weld, that is equal to 7 mm, and Q is equal to shear force. Shear force is 350 kilonewtons upon 2 times 7. So area is how much? Shear area is 2 times T into D. D is 350 mm. You can see along the D is 500 mm. Total it is acting along the length of 500. So this is 350 by 2 into 7 into 500 into 10 to the power of 3. So this gets cancelled. This is 50 Newton per mm square. And similarly, F, if you want to calculate, that is m by z. So what is the moment? Moment, that is equal to load multiplied with E. So 350 into 10 to the power of 3 newtons into eccentricity. Eccentricity over there is 100 mm is the eccentricity by 2 times z is equal to bt square by 6. So that is T is how much? 7 into 500 square by 6. 7 into 500 square by 6. So approximately this would be 50. So 50 into 3 into 10 to the power of 5 by 25 into 10 to the power of 4. This is equal to 60 Newton per mm square. So finally the resultant stress is equal to under root of 60 square plus 3 times what is this Q value? 50 square. So approximately you will get 109 point, he is asking 1 decimal, so 109.4 Newton per mm square. So very simple, you just have to analyze this one, and all these things are, this is from the code. This is from the code, so you have to remember this. And how to calculate those one? This is the shear area that is being resisted. Shear, all these things are taken as rectangle because this is very small in size. That's how you are going to calculate it. Thank you.